Okay, so in this video I'm going to have a look at Gantts charts, and in particular I'm going to have a look at this particular question here, which is a question on page 265 of a book called Fundamental Applied Maths by Oliver Murphy. Now the question involves this network here, which consists of a number of activities from A to N. The activities could represent any situation, any project, and the weights on the arcs represent time in days. Now I've taken a step backwards here. I've written out the dependency table here. So I have listed all the activities and what activities they depend on and the duration of each activity as well. Now I've covered this in a previous video called Critical Path Analysis, but I just thought I'd write it out again here. The first step that we want to take in this process is to write out the early and late times for each of these activities. So let's just work through that. Now I have the network written out again here, and I have another network here. Well, it's the same network, but instead of the nodes I've got these double boxes where I'm going to put the early and late times. So we're going to start here. We're going to put in a 0 and 0 here, and let's move up along here to A. We see that A has a duration of 10, so we're going to put 10 here. We see that B has a duration of 4 days, so we'll put 4 here. Okay, let's move to C then. Has a start of 10 days, it has a duration of 5, so that's going to give us 15 days here. Let's move to D then. Well, D has a duration of 4. We've got to start at 4, so it's going to be 8, but we also have a time of 10 days here, so you've got to pick the larger of the two, so we're going to pick 10. Okay, so that's A, B, C, and D. Let's have a look at E then. Well, E, we just take the 14, we add the 4, and that will give us 18, but we also have here 10 plus 9, which is 19, so we're going to put in the larger of the two, which is 19. Okay, so that's E. Let's have a look at F then. We have F up along here, so we've got to take this 15, add this 15 here, that's going to give us 30. Now we also can come up along this way, so we've got to have a look at that as well. G has a duration of 3 days, so we've got to add that to 15, which is 18. But we've also got this arrow coming up along here, H, so we've got 10 plus 10, which is 20. 20 is bigger, so we're going to put 20 in along here. Okay, so let's move down to, we'll actually move down here, I think, first. So we've got 20 plus 2, which is 22. We've got 19 plus 7, which is 26. 26 is the larger one, so we're going to put that there. So now we can finally deal with F. So we've got 26 plus 8, that's 34. And we've got 15 plus 15, which is 30. So the larger one, 34, we're going to put in here. And finally, now we can move down to our sync node. So we've got 34 plus 5, which is 39. And we've also got 19 plus 13, which is 32. So we're going to use 39. Okay, so let's start moving backwards then, do our backward passes, as they say. So let's move up along this way first. So we're going to take our 39, subtract 5, that's going to give us 34. We've got 39 here. So let's subtract 13, that's 26, so we could have 26 here. But I have another arrow coming down this way or in the opposite direction, so I need to have a look at that as well. So let's do this one next. So we've got 34 minus 8, that's 26, so that'll go in there. 26 is the lowest we can go there anyway. So now let's have a look at this one here. We've got 13 and we've got 39, so 39 minus 13 again is 26, and we've got 26 minus 7, which is 19, so we're going to go with 19. Right, let's have a look at this one then. We've got 26 minus 2, which is 24. It's the only one going in there, so that's fine. Let's have a look at this one. So we've got 34 minus 15, that's 19, and we've also got 24 minus 3, which is 21, so we're going to put 19 in here, the smaller of the two. Okay, let's have a look at this one. So again, we've got 24 minus 10, which is 14, and we've got 19 minus 9, which is 10. Smaller one is 10, so we put 10 in there. So we're also going to end up, because this is a dummy activity down along here, we're going to end up with 10 here. Well, actually we've got 19 minus 5 as well, which is 14, so 10 is smaller, so we're going to put the 10 in there anyway. Okay, down along this way then we've got 10 minus 4, which is 6, and we've got 19 minus 14, which is 5, so the smaller of the two is 5. And then finally our source node, we've got 10 minus 10, which is 0, so we have a 0 here already, that's fine. And 5 minus 4 is 1, smaller of the two is 0, so that's really it for our early and late times for this set of activities. So the next thing I'm going to do for this question is just have a look at the critical path in this network. I'm going to look at the critical activities, and I'm going to have a look at the total float times for two activities, F and G. Now the critical activities here are going to be up along this way, A, then we're going to come down along this way, then we're going to come down along this way here, up along here, up along this way, and then down to our sync node here. Remember, critical activities are activities that will have a total float time of 0, and the critical path is going to be the path from source to sync node, which joins all these critical activities. So our critical path then is going to be A, I, K, M, and N. And the length of that critical path, the length is 39 days. So let's have a look at the total float then for activities F and G. So if we take F first, this is F up along here, we've got to take 34, subtract 15, and subtract 15. So total float for F is going to be 34 minus 15 minus 15, which is equal to 4 days. The total float for G then, so let's see, where is G? G is along here, so we're going to take 24, subtract 15, subtract 3. So it's going to be 24 minus 15 minus 3, and that'll give us a total float of 6 days. Okay, so the next step in this process is to draw a cascade chart, or a Gantts chart as it's called. So what we're going to do first is have a look at the critical path in this network. So the critical path is from A down to I, K, M, and N. So we're going to draw that in first in our Gantts chart. So we're going to start at 0 and go up to 10 for A. So let's do that. We're going to start at 0 and go out to 10. This is A. So you guys probably want to use a ruler here. I'm doing this freehand. So the next one then is I. So I starts at 10 and goes to 19. So let's do that one. So it starts at 10 and goes out to 19. This is I. Next one is K. So K starts at 19 and goes to 26. And this is K. So after K then we've got to look at M. So M goes from 26 to 34. So we've got to go out to 34. This is M. So we've done A, I, K, M. So we've just got to do N finally. So N goes from 34 to 39. And this is N. Okay, so the next thing we're going to do is, we've looked at A, so let's look at B then. So we're going to look at B here. B starts at 0, goes out to 4, and has a float time of 1. We take 5 minus 0 minus 4, gives you a total float time for B of 1 day. So we're going to start at 0, go out 4 days. It has a duration of 4 days. So we're going to start at 0, go out 4 days, 1, 2, 3, 4. This is B, and it has a float time of 1, so we're just going to put dotted lines there to represent the float time. Okay, so that's B done. Let's have a look at C then. Well, C is along here. It starts at 10, it has a duration of 5, and it has a float time of 19 minus 10, which is 9, 9 minus 5, which is 4. So it has a float time of 4 days. So we're going to start at 10 and go out 5 days. We're going to start at 10. And we're going to go out 5 days to 15. I think that's correct. 1, 2, 3, 4, 5. There's 15. So this is C, and it has a float of 4 days. Again, dotted lines. Okay, so next one we're going to look at is D. So let's see where D is. Well, D starts at 4. It has a duration of 4 as well. And it has a float time of 2 days. 10 minus 4 minus 4. 10 minus 8 is 2. 2 is going to be the float time for D. So we're going to start at 4 and go out 4 days. 1, 2, 3, 4 is here. So we're going to go out 4 days. And it has a float of 2 days. Okay, let's look at E. So E is along here. It starts at 4, it has a duration of 14 and has a float time of 19 minus 4, which is 15, and 15 minus 14, which is 1. So it has a total float time of 1 day. Now it starts at 4 and goes out 14 days. Starts at 4 and goes out 14 days. And it has a float of 1 day. Okay, so that's E. Let's have a look at F. So F starts at 15 and it has a duration of 15 days. It has a float time of 34 minus 15 minus 15, which is 4 days. So we're going to start at 15 and go out 15. So we're going to go out to 30. And F has a float of 4 days. So that's F. Okay, next one is G. So G is down along this way, so you've got starting at 15, it has a duration of 3 days and has a total float of 24 minus 15, which is 9, 9 minus 3, which is 6. So G has a float time of 6 days. Okay, so that's G, has a duration of 3 days and a float of 6 days. H is next. So H is here. So we're going to start at 10. We're going to go out for 10 days and it has a float of 24 minus 10, which is 4. So we're going to start at 10 and go out 10 days. So we're going to go out to 20. This is H and it has a float of 4 days. Next one is I, but we've already done I up here. So the next one then is J. Let's look at J. J starts at 20, it has a duration of 2 and a total float of 26 minus 20, which is 6, 6 minus 2, which is 4, so it has a float of 4 days. So we're going to start at 20 and go out 2 days for J. So we're going to start at 20, we're going to go out 2 days and it has a float of 4 days. Okay, next one then is K, but we've already done K here, so it's going to be L. And L is actually the last one because we've already done M and N. So we're going to do L next. So L starts at 19, it has a duration of 13 and has a total float of 39 minus 19 minus 13, which is a float of 7 days. So we're going to start at 19 and go out 13 days. This is 19 here. We're going to go out 13 days and it has a float of 7 days. Okay, and that's our Gantts chart for this particular project. So just to finish this off, I just want to answer 2 questions, and these 2 questions here. At midday on the 16th day, which activities must be happening and which activities may possibly be happening? So let's have a look at the midday on the 16th day. So this would be day 1, day 2, day 3. So the first day is really between 0 and 1. The second day is between 1 and 2. The third day is between 2 and 3. So the 16th day would be between 15 and 16. So we're looking at here, this is day 16, this is day 15. So what we would do is just drop a dotted line down along here. So this is the time period that we're talking about. So which activities must be happening? Well, I has to be happening. There's no room for R here. There's no room for I to move to the right. So I has to be happening. So must, let's say must be happening. So which activities must be happening would be I anyway. Also, if you look down along here, E must be happening as well. Even if we push E out one day here, it's still going to be intersecting this dotted line here. So E must be happening as well. And let's see anything else. Well, G can be pushed out, so we might miss G. F here can be pushed out as well, so that's okay. But H here, even if we push H out 1, 2, 3, 4 days, this part here, this solid rectangle here, is still going to be intersecting this line here, this dotted green line, so H must be happening as well. So I, E and H must be happening halfway through day 16 or midday day 16. Okay, so which then may be happening? So again, let's move down along here. Well, it's intersecting I. We've already done I. What about C? Well, C here, we can see that C could be happening during this period of time here. It can be pushed out here. So therefore, C may be happening, may possibly be happening. Let's continue on down. Well, we've already done E. What about F? Well, F, in this situation here, F is happening, but F could be pushed out to the right here by 1, 2, 3, 4 days, in which case the green line would not intersect F. So F is another possibility here that F is another activity that may be happening. Let's continue on down. Well, you've got G here as well. If you push G out to the right here, 1, 2, 3, 4, 5, 6, it can go out 6 days. So that would mean that it would not intersect this green line. So G may possibly be happening. It is in the scenario that we have here because the green line is intersecting this rectangle, but G could be pushed out to the right here by 6 days. So therefore it may not be happening. H can only be pushed out 1, 2, 3, 4. Even if it was pushed out 4 days, it would still be intersecting this green line. So H has to be happening, and we have that here anyway. Okay, so really that's it for this video and this particular question.